So we're back working on this 2500 HD, and today I've repaired a section of the transmission cooler line with a new piece of hose and double clamps. We're going to fill the tranny up now and see how it performs. Also take note of how low it is. So we also have the new fuse panel here today, and in case you're interested, it's 19210439, although your part number may be different depending on what options your truck is built with. This is a pretty stripped down truck. It doesn't have a lot of electrical options. It's a four-wheel drive, regular cab. One of the areas where the salt tends to migrate in is right in this area here by these feed studs. So I'm going to fill this with RTV silicone just to try to keep the salt from migrating in through those feed studs in that area there, because I seen the other one was badly compromised in this area, and this is the first area that get attacked in here. So we'll go ahead and put this in and then start it up and fill the transmission up and see how it shifts. So the first thing I did was to confirm that all the relays and fuses are in the same spot on this replacement relay center, this new one from the old one. And the one thing I did notice that this particular relay, which is technically not a relay, it's a electronic relay, is missing in this fuse panel. So I figured, okay, maybe because that one's expensive they left that one out. So I pull it out of here. You can tell that there's terminals under here, and then I go to install it in here, and there's obviously no terminals under there. Everything else for the most part looks identical. There was one fuse here that was a 15 instead of the old one having a 30, but somebody's put the wrong fuse in there. And there's a fuse in here that I don't have in the other fuse panel. I'm not sure what that is, but that's minor. I phoned the dealership to ask them about this 1501-6745, which is a electronic relay, and according to this parts information, it has been eliminated with this new design. So how they deal with the fan or electroviscous clutch, or maybe this engine doesn't have it, I'm not sure, but we're going to just leave that out for now and put this in. Hopefully everything's going to work. So there's the new fuse panel installed. I put a new ring terminal on this accessory feed wire, I'm not sure what it is, and new nuts. And as I said before, I filled this area with RTV sealer because the salt spray tends to wick its way into the circuit board there. And then I coated the wires, the terminals, with battery post sealant. So that's locked down now, and I think all the fuses are in, and we'll see what kind of communication we have now and start it up and run it. So while this is warming up, we're going to see if we've got any more communication with anything here. We'll use this one here on the top of the list. Scanner. Probably no, I got power at the DLC now. Truck is running. Remember before in the previous shots we didn't have communication with anything on the low speed network. So I'm going to try and do a network scan again and see what it communicates with. I'll pick up when this is finished scanning. So here's the results. We've got 13 computers reported now. We still have a bunch of fault codes in the transmission computer because I didn't clear them. But now we have communication with all of these low-speed network things. I don't see the airbag system, the restraint system. So let's try and, oh yeah, there it is. My mistake. It was there. So we'll do a network code clear now and see if it will clear codes out of 12 or 13 systems. Go ahead and let this thing warm up and top up the transmission fluid. That's better. Now we got 13 computers reported and cleared. So let's go into the transmission computer and have a look at the transmission oil temperature. Should be in this data list, I would think. I haven't looked to see yet whether the gear selector shows correctly on the dash, but I seriously doubt it. That would be a nice thought, but transmission fluid pressure, I don't see temperature in it. I'm sure it's here somewhere. Hot mode off. Oh, there it is. 23. So I'm going to run this a little bit and then top up the tranny fluid. Well, it took 5 liters to top up the transmission fluid, and it's not up to temperature yet. So it was down quite low. The gear shift indicator still does not indicate drive when put in drive, and when I put in reverse now, the reverse indicator starts to blink. So let's see what codes came back, and I'm sure that we have some codes. Oh, shift solenoid valve performance, transmission fluid pressure switch. Yeah, here we go. Same codes. Well, less of them. 751, 843, and 877. I notice the engine light is back on, but it's probably a generic fault code for P0700. Let's check it. Yeah, that's just a generic code. P0700 indicates the transmission computer requested the MIL to be illuminated. So, that one's a secondary issue. So we still got some internal problems in the valve body, solenoid pack or something in this thing. That's frustrating. But we did clear up the network problems with the low-speed bus. We do have communication with the airbag now, I imagine. Yes. So we do have communication with the airbag module and all the other computers on the low-speed network, which we didn't have before, so the fuse panel fixed that problem. But we still have issues with the transmission, unfortunately. Okay, we'll have to do some more troubleshooting now. So here is the description for P0751, shift solenoid 1 valve performance stuck off. Now earlier I commanded the shift solenoids on and off with the scan tool while standing underneath the vehicle, and I could hear them all click on and off except for the torque converter clutch. But I don't have the torque converter clutch solenoid code. So the conditions for running the DTC as greater than 200 RPM, shift solenoid 1 is commanded on. It's commanded on and pressure switch 1 remains off for 5 to 12 seconds depending on transmission fluid temperature. Sets the transmission in a forward gear, will command another forward gear. If the DTC sets one in reverse, the trans will remain in reverse or shift to neutral. Freezes, shifts, adapts, inhibits torque converter clutch engagement. Is set in any combination with, if is set in any combination with 751, 756, 761, then diagnose 701 first, prior to proceeding to 751. Well, I also have 843 and 877. Check the fluid level and condition. Well, it's full now. Engine running now. Command the transmission through the forward ranges with a scanner. Verify transmission fluid pressure switch 1, 2, and 3 parameter states are correct for each forward range. Operate the vehicle within the conditions. Does it come back? So on. Let's have a look at the other 843 and 877. So 843 is also for transmission pressure switch 1. Detects pressure switches off or high when the shift solenoid is commanded on for 1 second. Let's try 877. 877. That's transmission fluid pressure switch 4 circuit low. Detects that the pressure switch 4 signal remains low for greater than 1 second when in park or neutral or forward range. Let's have a look at the electrical schematic for this. Well, I did find a TSB on Identifix, and it shows P0751, 843, and 877 as possible codes pertaining to this TSB, and it has to do with, well, first and foremost checking the fluid level, which I've done, although it's not up to temperature, it's not low on fluid. It says, if no other concerns are found, inspect for a stuck lube regulator valve item 13 in document 2384492 in the pump cover due to debris. Well, The transmission fluid looks fairly clean, but that doesn't mean there isn't a problem. This transmission, I understand, was replaced with a reman assembly a couple of years ago. So this is not looking good. So here's the diagnostic flow chart for P0751, and it says here that pressure switch 1 signal, if it's open or has high resistance, can cause P0751, P0843. But pressure switch 4 is not mentioned here for some reason, and I don't know why. Because that's what the P0877 code was, and this is for the Allison automatic. So again, we're going to have a look at the wiring diagram to see how this is designed here. Maybe we just have an open wire. We also have that problem with the manual lever range switch not indicating drive as well. So I printed off the electrical diagrams for this. According to this, it shows that the pressure switch manifold is a multiple switch assembly made up of 3 normally open pressure switches and 1 normally closed pressure switches. Pressure switch 1 monitors shift valve 1 positioning, pressure switch 2 monitors shift valve 2 positioning, pressure switch 3 monitors shift valve 3 positioning. The normally open pressure switches 1, 2, and 3 communicate the positioning of the transmission control module to the transmission. The position of the shift valves 1, 2, and 3 controlled by 3 normally closed shift solenoids 1, 2, 3. When energized, the shift solenoids direct control mainline pressure to the shift valve 1, 2, and 3, which strokes the shift valve. When the shift valve is stroked, an exhaust passage is blocked, and the fluid pressure to the pressure switch increases. So it doesn't mention that pressure switch 4. I don't know why. I'm not going to worry about it right now. But according to the schematic, and I'll bring it up here in a second. So here's the schematic for the transmission fluid pressure switch. So it shows 4 switches in there, of which it says 3 are normally open. And obviously there's a pull down circuit here because the switches supply ground. If that ground was bad, it would, and I think it's an internal ground by the looks of it. So we're going to find this connector at the transmission, this X175, which is right at the back of the transmission, and measure the voltage on these 4 wires. My take is that they should all be the same. I would expect 5 volts, but it might be system voltage or 12 volts. If we have the same voltage on pins D, F, E, and K, then I would say the wiring is fine and the problem is internal in the transmission. Either a failed pressure switch, which I believe that's what it is. Now the other circuit in question is the range sensor, and it's basically the same thing. Let's go back and look at that diagram. Here it is here. Internal mode switch. Same idea. 4 circuits, various arrangements of open and closed to indicate what gear position it's in. If one of these wires is compromised, it won't be able to indicate the correct gear, and that's my take on it anyway. So we're going to qualify these wires at the transmission first. So this is connector X175, plugs into the right rear corner of the transmission. I've pulled it down and I've opened the loom, and there's a lot of sand and grit inside the wiring harness. I don't see anything obviously wrong on it. I've got the key on, so I'm going to determine which terminals I have to probe here and measure the voltage on. So the first challenge is to orient this connector the correct way so we can figure out which pin is which, and then I determine based on the schematic that we need pins D, F, E, and K. So D, E, so D, F, E, and K. Wow. Okay, let's have a look. So, I think I figured this out now. I got confused because I was counting the alphabet. I learned the alphabet off of Sesame Street several decades ago. And I forgot that I have to know the GM alphabet, where they leave the letter I and O out. So this is pin D, and it's 4.75 volts. E, 4.73 volts. F, 4.73 volts. D and K is 4.73 volts. So those circuits are all good up to the tranny. I mean, I suppose I could check and wiggle the harness and such, but I don't think that's a problem. Moving the harness going into the tranny and up to the engine. Let's check the other circuits on the range switch. The other circuits on the range switch are pins, let's see here, oh man, I can hardly read that, T, U, and V. T, W, U, and V. T, so that's the bottom row. So, that was the top row, this is the bottom row. 4.75, 4.75, 4.75, 4.75. Now I would expect if I were to ground any one of those four wires, the switch would change state on the scan tool. But given the fact that we have basically 5 volts at all the pins down here at the computer, or at the actual transmission, as nasty as this harness looks, it appears to be okay, and the problem appears to be internal in the transmission. So pressure switch and a range switch is what we're going to need for this thing, as far as I can tell. And I guess we're going to have to put a filter and gasket in it as well while we're here. We might as well. Hopefully that's going to correct all of the problems. So I'm looking at the transmission pressure switches right now, and I just put it in drive, and you can see here's transmission pressure switch 1, change state, transmission pressure switch 2, 3, and 4, they all change state when I put it in gear. Actually, pressure switch 2 doesn't appear to have changed state, this one here. But the reverse indicator is not blinking anymore. The drive indicator still doesn't work. I'm just curious as to what codes might have come back now. Isn't that special? All I did was clean that connector and plug it back in. It was full of sand and grit. I'm going to take it for a road test and see how this thing performs. So I just got back from about a 12-kilometer road test at highway speeds and various stop and goes, and the only noticeable complaint that it has right now is a firm 2-to-1 downshift, and the other indicator is that the gear shift indicator does not display drive. There's a mechanical issue with the shifter cable. It won't allow it to go into manual or low, but that's a secondary issue. Let's see if there's any codes that came back. The transmission seemed to work just fine, and look at that, no codes came back. So one of two possibilities: either the transmission was so low on fluid when I topped it off that even after I topped it off and filled it up, there was still air trapped in various passages, and that caused the pressure switches not to change state accordingly. Because all I did was take the connector apart, look at it, clean it. I did clean the connector on the transmission. It was full of sand and grit, but as far as I could tell, it was properly plugged in. I tested all of those circuits to the transmission, plug it back in, and now it's good again. Or did the air just work its way out of the system? I'm going to recheck the transmission fluid level and have a look at some of this data that I just recorded. So although this thing is not completely up to temperature, it's only 48 Celsius, which is around 120 Fahrenheit, I think. It wasn't even at the cold mark after adding 5 liters. I had to add another 2 more liters to this thing to bring it up to the warm level. So obviously it's been leaking for some time. That cooler line was seeping, but it didn't look that bad. So somebody's been neglecting this thing, not checking the transmission fluid. Oh well, it still has an internal problem with that manual lever position switch.